In this video, I'm looking at seeing which two of these three triangles are similar. So similar triangles all share the same ratio of sides because they're just scaled versions of each other, or they have exactly the same angles. So because we can't see any angles, I'm going to look at the sides. So if we look at the first triangle and the second triangle, we can see that if we look at the shortest two sides, they are exactly the same. But then if we go and look at, say, the next shortest two sides, they are different. So this would be a scale of 1 between these two sides, but this would be a scale of something greater than 1. But because we want all three sides to have the same ratio, this is not going to be, these two are not going to be similar triangles. So I'm going to have a look at the first and the third triangle. Now, so that I can talk about different lines, I'm going to label these three triangles. So I'm going to have triangle A, B, C, and I'm going to have triangle D, E, F. So that's going to enable me to talk about different sides. The first thing I'm going to do is find the scale ratio between the two short sides. So I'm going to have a look at the scale between E and F, so the distance from E to F, and have a look at it compared to side AB, because it's the shortest side on my first triangle. So the distance between A to B. So this comes out as giving me the fraction that the distance between E to F is 3, and the distance between A and B is 2. So we have the scale 3 over 2, or 1.5. So this side, EF, is 3.5 times as big, or 3 halves, 1.5 times as big as the side AB. So now we can have a look at one of the other sides. So we can check the two medium sides, so 3 and 4.5. So if I have a look at the side D to E and compare it, so this side here, to the side C to B. So the side C to B, and we'll have a look at what ratio that comes out to be. So we have 4.5 over 3. Now this is a bit harder to see what the actual scale is, so let's have a look at simplifying this. So this is 9 over 2 over 3, because 4.5 is 9 over 2. So this gives us 3 over 2, simplifying that fraction, or playing with that fraction, I should say. So we divide the 9 by 3, and we get 3 over 2. So these two are sharing the same scale factor. So far, these two triangles are coming out to be similar. So all we now have to do is just check the last side. And so we have D to, no, we just did D to E, so we want D to F. So we have D to F, and we want to check it compared to the longest side over here, which is the line AC. So we want to see what this comes out to be. So if we have a look at that, we have D to F is 6, and we have A to C is 4. And if we simplify that, we can divide both of these by 2, so that comes out as 3 over 2. So all of these came out. So therefore, E to F, or we can write up the scale factor statement that says what all of these are. So we have that E to F over A to B is the same as D to E over C to B, which is the same as D to F over A to C. So that means that these two triangles I should say, that means that triangle ABC is similar, whoops, if I put the C in there, is similar to triangle DEF, because we use the side comparison. So that's it. By checking the three sides, And seeing that they have the same scale factor, the same ratio of one side over the other, we can say that these two triangles are similar through side, side, side.